First of all, I will show you how it works, the application. We have here in the interface two 7-segment displays and 3 buttons. The first one, the set function. So if I press one time, I can turn on all the 7-segment displays. If I press a second time, turn off the 7-segment displays, and the third time I can see how the dot point segment in the 7-segment displays are turned on. In this stage, I can configure the initial count with this second button. So if I press one time, I configure 5 seconds. If I press a second time, 10 seconds, 15 seconds, 20 seconds, 25 seconds, and so on, depending what I like that could be the initial count. So if I want that 30 could be the initial stage, so I can to start the countdown. In a previous video I show you that I press the count button, but I did a change. So to start the count, I should press the set button, so I can to start the countdown until reach the 00 numbers in 2 7-segment displays. So I can stop the count when I want, or restart the count in the number that I have until I reach the 00. After this, I can't do nothing. So what's the purpose of this third button? When I press it, I can blink or turn on and turn off the LED built-in LED that is put in the Arduino Nano PCB. So the only purpose of this button is establish a blink function that is concurrent with the function of all the system. So the effect is not so clear in after of the countdown reach the 00 state. So I'm going to restart the system. We can to restart the system again. So I'm going to press one time the set button, 2 times to turn off, and the third time to configure it the initial count: 5, 10, 15, 20, 25, and I press again the set button. So in this countdown, I can to press the count button, and I can see how the 7-segment displays are count and the LED built-in is blinking at the same time or in a concurrent way. So I can stop the blinking when I press the count button again. For example, here, oh no, well, here remains in the state, the current state. So this application was developed to help to application that was developing our friend Taral that is live with us. So this is the execution. To complete the application remains some aspects, but we can do this in this live session. So I'm going to explain a little the code based on the running state that I've shown you. So I'm going to explain the code. So if I go to my code, or the code of application, I can see that I wrote 251 lines and interesting functions. Here we, or I, in this case. Okay, Taral, thank you. So when you don't understand me, please tell me and I'll try to repeat as better as possible. And everyone, I'm going to answer the questions in English or in Spanish for Facebook or here in YouTube. So I'm going to explain a little the code with some details that are important to build the whole application. So the hardware, depending if you have any doubt, but the goal of this session is explain especially the code. But we cannot very complex hardware. We can see that we have the Arduino Nano here, or the Arduino Uno. They use the same microcontroller at Mega 328P, some capacitors, the crystal obviously to the clock, a reset button, a LED built-in, but not so much. Here, especially to build the application, I used a digital ports or common ports to avoid a lot of wire, because it's awkward. I don't know, put a lot of wire in the design. So I think that is so good to use the ports for a better structure of application and order too. So we have here the integrated circuit 4511, that is a BCD to 7-segment decoder, and we should to switch between the cathodes of 7-segment displays to turn on one at a time. We cannot turn on the 2 7-segment displays at a time because it's a lot of current since or from this integrated circuit. The current is limited since each port, so we cannot give some current or a lot of current, limited to 20 milliamperes. So that's important, this part, and understand how to control the transistors to turn on and turn off the displays, and to do a swap between them and avoid to turn on the 2 7-segment displays at a time. If I turn on, that is part of application obviously and my code, if I turn on the left 7-segment display, I should to turn off the right 7-segment display. And in the other way, if I turn on this, I should turn off this. Well, these concepts I will to explain in the way that are required in the code, obviously. So The first part of my code, that is write or wrote in C++, C and C++, because Arduino is not a language, so I'm going to use macros. I'm going to use arrays. Here I have another array, 1D array or vectors, and 2D array or matrix. Configuration, this function that is very common in the Arduino programming. Some variables, global variables in this case, explained according to the specific function. The loop function and some other functions that I used in this application. Well, is an overview of all the code. Well, here we have two macros. One macro is named data ports. Data ports correspond to the amount of ports that I've used in the control of the 4511 inputs. So I should control the port A, B, C, and D. And for this port, I should to input the binary code to B, the code for this integrated circuit, to represent it in the 7-segment code. So 4 ports for this. So this macro data ports corresponds to these ports A, B, C, and D. Conf ports correspond to 10 because I should control 10 digital ports, not only the inputs but the control inputs of 4511, the lamp test, the PI, and the enable, obviously. That corresponds with digital 6, digital 7, digital 8, and digital 9 correspond with the with dot point of 7-segment displays. It's easy to follow these connections because these names corresponds with the names of each of ports of my microcontroller. So we have D2, D3, D4, D5, D6, D7, 8, 9, 10, 11, 12 here. For these buttons, change and count, I'm going to use A0 and A1. These one are analog ports, but in microcontroller you know that we can use one port with many functions. For example, A0 we can use like a digital port or analog port too, or to do an interruptions. We have here 3 functions for this port. For example, we can use the pin 15 like digital port PV3, like MOSI, to use SPI communication, to use like timer that is represented with OC2A, and we can use it like interruption too. So for this application I'm going to use the analog ports, specifically A0 and A1 how analog inputs, because these buttons represent a digital input to our microcontroller. Well, so in order of ideas, I was explaining that I need 10 ports to configure all the system, and here we have 4 for data, another 4 for configure the state of 4511 integrated circuit. So we have 8 ports, another port D10 to control this transistor and PN transistor to control the activation of the 7-segment display. So we can see that the collector is connected to Z1 and Z1 is connected to common of the 7-segment display. And important information is that this 7-segment display is cathode common. Well, so to see any number, we should to send high states, and the same thing we can do with the another transistor to control the right 7-segment display. So we have here 4 to data, 4 to control, another 2 for control the transistors, and we have here 10 configuration ports. So that's the meaning of this macro. Conf ports are 10 for that reason. Well, we can see here that each information, for example, I have connected the digital port 2 to our A port. How we can see here, look, the 2 port of microcontroller is connected to input A in the integrated circuit 4511. So I'm going to write the macro or express this information with a macro to simplicity. So A port connected to digital port 2 in the Omega 328, B port to digital port 3, C port to digital port 4, D port to digital port 5 in the Omega 328, and so on. The LT port connected to DCs, we can see here. BI port connected to digital port 7, here we have it. LE port connected to 8, we can see here. D9 port connected to dot point of 7-segment display, and K1 and K2 connected to base of each of these transistors and PN transistors to activate or deactivate each one of the 7-segment displays. And for this reason I have these macros. Another macros are configured to control the input buttons. So in this case, D12 with the D12 port of our microcontroller, I'm going to control or read the state of this button 1. This is the button 1. Button 2 is connected to a digital port A0. We should name with this name specifically in order to the compiler understand that we want to use this port that have this name. We can use it like a digital port. So in this moment, the compiler don't know it, but in the instruction, this here, I will show to the microcontroller that I want that this port that is by default analog port, I want to use it like a digital port. So I use button 2 connected to analog port 0, that in this case I will use it like a digital port. In order to the explanation that I gave you a couple minutes ago. So I have here all the variables or macros specifically, and with this information I avoid to use these numbers without meaning. So I prefer this way because when I give to this array the name of the variable, I know that in background the compiler assigned this number. Obviously it's shorter, but I prefer this way for explain better in the best way the code. So the utility of this array or vector is to do an easier way to configure all the ports, all these 10 ports, those ports. So are 10 ports, so I prefer to assign it to an array of 10 positions, and I don't know, give this array to a for loop and make initialization in 3 lines of code and avoid a bunch of unnecessary code. So I'm going to assign to vector, and I'm going to explain what's the reason, and after of this I define a control port 7 segment with 4 positions because I use this vector to configure the ports and use this vector to use the ports. So in the first stage of the code I should configure it, and after of this I should use all my system. Well, that's the reason, because Arduino have a setup function and have a loop function, because we should to configure it in the first stage of the execution. Well, so I use this array to configure the ports, and this one to use the ports and send information to the ports. Well, what's the reason to do this array or matrix or 2D array? Because if I want to see the 0 in the 7 segment display, I should to send 0, 0, 0 for each one of the ports. So I'm going to comment here. So I no, for the way that I'm using this vector, here is the C, B and A. And we can see that when I send 1 to A port, 0 to B port, 1 to C port and 0 to D port, I can to see the 5 in the 7-segment display. If we see, we have the macros, the variables, here the vectors. So I've tried to explain the better way the meaning of use these variables and macros. So in this part I'm going to explain the functions. The first one is the setup. The setup is to configure the ports, because this function is executed one time. So that means that we should to configure everything in this function, or put any command that requires only one execution. So after define these vectors, I'm going to use the for loops to configure it. So I'm going to indent a little for be more clear. Not here. Yes. Here. Here. Yes. Well, the first thing that we need to do in any use of microcontrollers is define the use of ports. In this case, with this instruction, I'm saying to the microcontroller that I want to use hold these ports A, B, C, D, L, T, B, I, L, E, dot point port K1 and K2 like outputs with this function. If you notice, I'm using the vector, obviously with I index, and I'm saying that I want to use like output port. So I use the pin mode function with all the ports that I want to say to the microcontroller that I want to use it like output. So I'm using in this way. The second thing that we need to do is set the initial state. So I should to say to microcontroller, if I want to use like output, well, it's done here. But after of this, I should to say to the microcontroller if the initial state of this output is in a low state or in a high state. With regard to Arduino, is 5 volts or 0 volts in the output. Well, so that's the things that I'm doing in this part of code. So I'm saying in this what? Configure the port BI and the port dot point in a low state. So send a 0 and a port different of these conditions. So the another ports configure it in a high state. Well, that's I'm saying in this instruction, this conditional.